Okay, so here we are. This is the video for May 4th through 11th, week 3, lessons 5 and 6. I think I talked about this in the last video, but let me mention this again. You all have access to Office 365, whether you go start.hcps.org. I'm not sure what your page looks like. It won't look exactly like this, but you will have Office 365. I used to send this out a few years ago, portal.hcps.org, and you log in. In case you're not sure, you log in with your email address and then your same school password. I think now this probably takes you to this same place. Nonetheless, you have Office 365. I keep telling people this. Make sure you know that you have access to all these Office 365 apps, so you can use these online, Word, or you can download all of them and work offline with them. I mentioned this just because some of the things, the way that you're submitting things, which is fine, however you want to do it, but to make it easier, you can just use Word or Word Online and drop it right back into that submission folder. Some of the things I've seen submitted, I've actually seen people taking pictures of their computer screen, right? On their computer screen, they were working on their Word document on their computer, and then they took their camera, their phone, and took a picture of the computer and uploaded the picture. So if you're already working on the Word document, I'm not sure why you wouldn't just upload the Word document into the folder. Maybe there's a reason that I'm not aware of, but if you want, if you're not sure about this, I think this will still get you there, but there's definitely a way. I want to make sure everybody knows that you have, if people are saying they don't have Word or they don't have Word Online, it's right there. HCPS makes it available to all of those, okay? If you're not sure, email me, we'll figure it out. Anyway, it's going well. Things are being submitted quite regularly, so that's good. Keep up the good work. So this week then, May 4th through 11th, week 3, lessons 5 and 6, just like before. So lesson 5 has the slideshow and the Word document right there. And then you just back up, and then there's where you submit it right there. Again, no need to email me anything. Just submit everything right in there. Okay, so let's go through real quick a couple things. So here's week 3, lesson 5. This is where we are. Things you learned from last week. So, or maybe you already know. So white light goes through a prism, breaks it apart into all the colors of the rainbow: red, orange, yellow, green, blue, violet. And so you learned this. The only difference between these colors is the wavelength. This is in nanometers, billionth of a meter. So if you look at a red shirt, or you're looking at my green shirt here, the difference in the color coming off them is just the length of the wave. It's the same type of energy, okay, where the red end is the lower frequency, longer wavelength, right? And that the violet end is the higher frequency, the shorter wavelength. So if we took red and we could stretch the wavelength out a little longer, it'd become infrared. Our eyes wouldn't see it. If we made violet a little bit shorter wavelength, it would be ultraviolet, and our eyes wouldn't see that either, okay? So what we realized then, we've got this visible spectrum, where the only difference is the length of the wave. That's what determines different colors. And then we realize there's all these other types of lights, we call them, but really this is visible light here. Radio waves, microwaves, infrared, ultraviolet, X-rays, and gamma rays are all different types of electromagnetic radiation. And again, the only difference between them is the length of the wave. So as the red light gets longer wavelength, it becomes infrared. Even longer, it becomes these real long radio waves. And then we go the other direction. shorter violet becomes ultraviolet, and then shorter high energy becomes X-rays, and then real high energy is gamma rays. And this little tiny sliver right in the middle is all that we can see. All of these wavelengths are being sent out all through the universe by stars and everything. They're all over the place. The only ones that our eyeballs can see is this little tiny part of the spectrum here that we call visible light, because our sun peaks in the visible part of the spectrum, so that's probably why our eyeballs can see that. There are insects that can see in ultraviolet. There's snakes that can see in infrared. We can make infrared goggles, right? Night vision, detecting heat. And we have telescopes that can see in every part of the spectrum, so we can look through the universe and then we can see any object in any part of the spectrum. Color only exists in the visible part, so we would add color to those to understand what we're looking at. And there we go. Again, so here's the length of the wave. Real short wavelength, higher energy. That should make sense. The shorter the wavelength, the higher the frequency and the higher the energy. We talked about wavelength earlier this year, I believe. And then the real long wavelength on this end. So those are radio waves is what we're dealing with today. Okay, how does AM and FM radio work? You've probably noticed, if you ever listen to AM versus FM, different things on there. You can hear them different places, different strengths, maybe in tunnels. One of them will cut off, one of them won't, or maybe one's mostly talk radio, one's music, and there's reasons for all of those. So that's what you're going to be looking at in this lesson. And here's your question to think about: how does your car radio receive a signal so that you can listen to music, ball game, or talk radio? So just want to mention here that you don't hear radio waves. Radio waves are picked up from the antenna of your radio, and then your radio will convert the electromagnetic energy into sound waves, right? So those are two different things. There's electromagnetic energy there traveling through space. Remember when we talked about sound waves, we said it had to have a medium to propagate through, air or table or whatever. Electromagnetic energy does not need that. We know that because we can see the sun and we can see stars. So it travels through the vacuum of space. Okay? So it has you. Here's another one of these FET simulations. And if you can't get it to work, again, it's tricky. Remember, you got to save. Even in school, it's tricky to get it to work. You're going to be filling this out, but if you can't get it to work, you can just watch these Khan Academy videos. They put those in there. All right. And so you're using this, and you're going to, on your document, there's numbered little statements, and you're going to put them in the right place where you think they go. AM versus FM. Okay. Pretty straightforward. And then a guiding question at the end. And then for lesson number 6, let's take a quick look at that as well. Really just one kind of thing I want to mention here. So here it is, week 3, lesson 6. How does a digital watch know what numbers to show? So you could think about those. There's a little video about time there. What we want to get to is this page here. This might be confusing to look at. And it gives you a little extra understanding here. So when we look at this little digital output, which is this, it's lettered A, B, C, D, E, F, and G. You can see right there. Actually, let's look at this. So let's look at that right there. If we scroll down here, it tells you here's the way the numbers are ordered: A, B, C, D, E, F, and G. So that correlates to these here. So for instance, if you wanted the computer or the LED to show the number 9, you would type in 1001 in the computer, and this is the binary code for it, 11111011, and that's telling you one is on, one is on, one is on, one is on. 0 means not lit, okay? And that's all those letters. So if we were to find 1001, there it is right there. And so it's saying everything except for letter E is turned on. See, so that's E there, right there. Lost it. There it is. And that makes the number 9. Okay. So you could look at any of them. There's to make a 0. The binary input is 0, 0, 0, 0. That's it right there. So everything is turned on, meaning a 1, except for the letter G, which is the middle one, and then how it registers on your clock is 0. Okay. So you end up figuring out a couple of those. By going through the slideshow. Okay. Revisit. Any questions? Please feel free to email. Hope everybody's doing well still. Keep up the good work. It's really going great.